Hi everybody, going to run through the revision paper for the EPMATH126 final. Now, we start off with types of numbers. Now, real numbers versus imaginary numbers, not every number is either real or it's imaginary. And the only thing we cared about with imaginary numbers was if I tried to square root a negative. So am I trying to square root a negative, square rooting 2? No, then it must be real. Am I trying to square root a negative with minus 5? No, then it must be real. That's it. So the only way I'm ever going to tick the imaginary number column is if I'm squaring a negative. I'm not going to tick it for something like negative square root of 5. There might be a negative, there might be a square root, but I'm not actually square rooting a negative, sorry. So, no, if I'm not square rooting a negative, it's real. Rational versus irrational. The formal definition of rational was it can be written as a fraction, but that's a bit of a slow way to think about it. I don't want to try and think of, can I convert everything I know into a fraction? The quicker way to think of was what were the only irrational numbers we dealt with in this course. The only irrational numbers we've dealt with is pi, because irrationals go on and on and on forever, their decimal part, with no repeating pattern. So pi is irrational. The only other things that were irrational were these square roots that didn't end up being whole numbers. I'm not going to write root 4 because that's 2. But root 5, root 6, all of these things go on and on and on. It's, in other words, if you think of your times table and you've got your 1, 2, 3, blah, 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 and I've got this column down the center, or down the diagonal, that's doing this. If I'm square rooting anything in that diagonal, I get a nice number. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so on. So square rooting all of these, they're not irrational, they're rational. They're just whole numbers, they're integers. But if I square root any number in between them, like root 2, root 3, root 5, 6, 7, 8, root 10, so on, they're irrational. So root 2 is irrational. Minus 5, no, that's rational. It's not pi or any of those square roots, so it must be rational. Integer is a whole number. We know root 2 is not a whole number, but minus 5 is a whole number. It doesn't matter that it's minus, it's still a whole number, which is definition of integer. And natural number. And just realised I removed that from the course, so I'll make a note. That's a good time to realise that that column is probably not on your sheet that you're looking at, which is good. Okay. Evaluate the following. Well, 7 plus 6 times 5 divided by 4 minus 3. It's BODMAS, which says do your brackets first. Got none. Do your OVs, or your power OVs, your square root OVs. Got none. Okay, do your multiplications and or divisions. So this is my middle bit. This is my most important bit. And what do we do first? Times or divide? Neither. You just go left to right. They're equally important, so I'm going to go left to right. So I'm going to leave the 7 plus there. 6 times 5 is a 30. I've still got my divided by 4, and I've got a minus 3. So the plus and minus are still going to stay there. It's still going to be 7 there and a minus 3 there. A plus 30 divided by 4, well, it's still going to be plus. And what's 30 on 4? I could go to the side and do a division, or I could halve it and halve it again. Or I could think as a fraction. What's 30 divided by 4? Well, it's the same as 15 on a 2 if I halve top and bottom. And what's 15 on 2? Well, that's a 7.5. So my questions become 7 plus 7.5 minus 3. Well, let's just go left to right. That's 14.5 minus 3, which is 11.5. Okay. Next, I've got a minus 2 in brackets squared. And I know that in brackets means get all of what's in here and times it by itself. So that's got to go positive. Plus, I've got a square root sign under that square root sign. The plus doesn't beat the times, so I've still got a 6 plus, and 2 15s is 30. I want a 7 minus 2. Well, that's effectively bracketed, so that's important to do now. It's trapped under that square root sign, there's implied bracket, 7 minus 2 is 5. Under that square root sign, now it's become root 36 over 5. Root 36 is 6, which is a 4 plus 6, that's 10 on 5, which is 2. Please lay them out like this with these equal signs aligned, and don't just scribble all over this and do that sort of stuff. Set it out mathematically. It sets out for undergrad. It also gives working, and you'll get a lot of marks for working. So many of these, it's not about the final answer, it's about the working. when you skip steps or make it messy, yeah, we lose a lot of marks. Now I've got an estimate question. The best estimate for this times this, well, let's just go to one significant figure. When we first learned it, we didn't refer to it as one significant figure. But now that we've learned significant figures in B4, we can call it that way. That's what we're doing, really. I'm saying, look, I'm just going to call you a 2. Should I round you up or leave you alone? Well, it's only 1, so I'm going to leave you alone as a 2. But there's 1, 2, 3, 4 digits I'm ignoring, so I've got to give zeros there. It's still got to be the size of like 20,000 times 26. Well, 26, I'm just going to leave 1 digit. I'm going to round it up because it says 2 is followed by a 6, so it's a 3. And there's 1 digit there, so 20,000 by 30. If I just do the 2 by 3 is 6, and then count how many zeros I just missed. 1, 2, 3, 4. So the 2 by 3 is 6, and there's 5 zeros on the end. 1, 2, 3, 4, 5. Now that doesn't mean the answer I'm looking for must start with a 6. We're looking for the closest. What's closest answer here to 600,000? Well, luckily enough, there is an actual 600,000. It's a long way away from 50,000 or 52,000. Long way away from 5.2 million. But even if this was a 5 or a 4, it still would have been closest. 600,000 is closer than any of these other way off numbers. Either way, it was D. Okay, now we've got a division, which I prefer to do as a long division, but in this course it's not compulsory. You might write down your 12 times table down here, you might know it, or it might be on your resource sheet. I'm just going to do it to there and say 12 plus 12 is 24, plus 12 is 36, and then 48, 60, 72, 84, 96 becomes 106, 108, plus 12 is 120. 10 12s is 120. I never need this answer, but I just like to check that because I know what 10 12s is, 120. Now let's do the 2, 9, 6, 2, 5 divided by 12. 2, 9, 65 divided by 12. Again, do it short division if you want, but I'm going to do it long division. 12s coming out of a 2 doesn't happen. I can't get 12s out of a 2. 12s out of a 29, I can definitely get 2 12s is 24. I can't get 3 12s is 36. But 2 12s is 24. So instead of doing 29 minus 24 in my head, I actually write the 24 and do my subtraction here. 29 minus 24 is a 5. Bring down the next number. 12s out of a 56. Well, 5 12s is 60. That's too much. So I've got to go this one. 4 12s is 48. 4 12s is 48. So what's 56 minus 48? Note that I couldn't have taken 5 out. I can't take 60 away from a 56. So here you can do the subtraction whatever you want. I walk from 48 to 56. It's 2 steps to 50. It's 6 steps to 56. That was 8 steps. Bring down the 2. 12's out of an 82. Well, 84 is too much, but I can get 72 out of it. 6 12s is 72. My subtraction there gives me 10. The last number I can bring down is a 5. How many 12s can I get out of 105? Well, I can't get 108, but I can get 8 12s is 96. If I do my subtraction there, it's 4 steps to 100 plus another 5 steps. 4 and 5, that's 9. Now, initially when we did these, we wrote R9. That's not wrong, but this says leave your answer as a mixed fraction. What's a mixed fraction? It's a whole number part and a fraction part. There's the whole number answer. Here comes the fraction part. 9 over. Now everything here, this whole number's been divided by 12. The remainder should get divided by 12 as well. And then I keep reading and it says R in simplest form. So, okay, I'll top it off by saying the answer is 2, 4, 6, 8. But I can see that I've got 3's in common. 3 3's on the top and 4 3's on the bottom. So my final answer, that's a mixed fraction. 2, 4, 6, 8 and 3/4. Next bit, so the steps that could be taken to simplify 5 times 292 for mental multiplication. Mental multiplication means don't just go and do 292 by 5. I mean, if you want to do that, just to know the answer, I won't say cheatery, I just did, but it's smart. Okay, 2 5s is 10, 5 9s is 45, plus 1 is 46, 2 5s is 10, plus 4 is 14. That's okay, but put a line through it. Make sure the marker knows that's not your answer. Like, that's not mental multiplication. That's our algorithm. Mental multiplication was the techniques we learned to do it in our head, no pen and paper. But we want to write down the steps that we're thinking in our head. Now there's two main ways I'll answer this one. I'd either think of it as a number near 300. I could call 292 300 minus 8. Or I could just say, look, it's 5 200s, 5 90s and 5 2s. They're all good, both good answers, and there's others. Let's do both of them. I could call 292 a 200 and a 90 and a 2. In other words, I'm saying, I don't know why I put those brackets there. I wouldn't really always write it out in full like this. I'm just trying to make a point. Then I'm just going to expand. 5 times 200, that's 1,000. 5 times 90, well that's 450. And the 5 times 2, that's a 10. So 1,000 plus 450, well that's 1,450 plus 10 is 1,460. And I don't mind that I've got that there. I can see I got it right. I'm pretty happy. Drink. Water, thank you. Come on, 10:15 in the morning. I'm at work. The other thing I could have done is said, 292, you're 300 minus 8. And we're still allowed to do a distributive law there. It can be a plus or a minus in there. 5 times 300, well that's 5 3s is 15 with the 2 zeros. Minus sign, 5 8s is 40. What's 1500 minus 40? That's a 1460. So either of them, a big fat or, either of them were great ways to do that one. So the steps we take to simplify that for mental subtraction. Again, if you want to do the real thing to the side to know your answer, we'll check it after. Let's just look at it. For mental subtraction, so in other words, what might I do in my head? I might say it's 423 minus 200 minus 90 and minus 4. I don't really think that's much easier. I think what would be good here is subtracting 300 would be so much easier. So there's a few ways to do it, but I like equal addition. It's only used for subtraction, which sounds odd, but that concept was I can add whatever I want to this number, as long as I add it to this number, and the gap between them still remains the same. If I add the same number to both, it's still the same answer. Okay, so the difference between the numbers remains the same. So this question becomes 429 when I added this 6 minus 294 becomes 300. Look how easy that is to do now. 429 minus 300, that's a 129. Again, lots of ways, but look at that. The other thing I couldn't, I suppose, it's a very subtle difference. I could have said it's 423 minus 300, which is 6 too many, but then plus 6. That's the same thing. 423 minus 300 is a 123, but I better add that 6. I took too many off by taking 300 off, and it gets me back to 129. All good. And of course, if I was going to do this check to the side, well, fine. I'll steal off the tube, take it back to 1. 13 minus 4, that's 6 steps, 7, 8, 9. 1 minus 9 I can't do, I'll steal off the 4, take it back to a 3. 11 minus 9 is a 2, and 3 minus 2 is a 1. Yep, but please cross it out, okay? Don't let that be the thing the marker thinks, oh, you think that's mental subtraction? It's not. That's the algorithm. Convert 216 base 9 into base 10. Main thing people have issues here with is if I drew the boxes, they'll go, oh, I know this. And when I don't draw the boxes, they go, no, I can't do these. Draw your own boxes. Here we go. Wow, that's a bit bigger than necessary. By boxes, I mean, what are the base 9 boxes? Well, all the boxes start on right with a 1. 1 times 9 is 9. 9 times 9 is 81. 81 times 9 is 729 if I wanted to go there, but I've only got 3 digits. So here I'm doing my face place actual. My place values are there. They're base 9 place values. Start with a 1 and times by whatever the base number is. The face values are just the digits I've got in the question. It's at 216. And face times place always gives you the actual. So this doesn't mean 2 times 100, which it would if this was number 216. It's smaller, it's only 2 81s. 2 times 81 is 162. This doesn't mean 110, it's only 19. 1 times 9 is 9. This still means 6 ones is 6. So if I add up all my actual values, I'll just go to the side and say, well, what's 162 and a 9 and a 6? I'll say the 2 and the 9 become 11, plus the 6 becomes 17. 7 down, 1 up. becomes 7. 177. That's it, 177 base 10. I'll write that just to... So, yeah, there's my answer. 177 in base 10 is the same as 216 in base 9. Next one's talking about divisibility by 8. And when I look at my... maybe it's on my resource sheet for my divisibility test. Initially, yes, true, I could just divide that number by 8. And if I get no remainder, the answer is yes, it's divisible by 8. If I get a remainder, the answer is no. But our divisibility tests tell us, look, you won't have to check the number formed by the last 3 digits. That'll do the job. I know that all of this number, 000, is already divisible by 8. So all I've got to do is check this. So instead of checking the whole number, save some time, reduce the potential for mistakes, and just test the last 3 digits. This is only for 8. If you don't know the divisibility rules, just chuck them on your resource sheet, and yeah, you'll have them. 8's coming out of a 4. I can't get 8's out of a 4. Oh, needed, David. 8's out of 46. What have I got? 6 8's of 48. That happens a lot, and people think with a gap of 2. But no, I can't take 48 off of 46. Remember, when you're trying to see what you can take out of it, don't take more than possible. You can take equal to 46 or less than it, but you can't take more than it. So 6 8's of 48, that was too much. 5 8's is 40. Yeah, that'll do. 5 8's is 40. That leaves me a remainder of 6. And now, okay, for some reason I'm doing this long division. I don't know. It just felt right. How many 8's out of the 62? Well, that's not going to be precise. 6 8 to 48, we said 7 8's of 56. 8 8's of 64, that's too many. 7 8's of 56. The gap here is a 4, 5, 6. I've got a remainder of 6. Now here, I don't care whether you write R6 or if you write 6 8s or if you write 3/4. The whole point is, I got a remainder. Therefore, no. Not divisible by 8 as division by 8 gave a remainder. Sweet. 845 is equal to what in mod 11? In other words, I've got like a clock with 11 things on it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just pretend that's 11. And it says, if I go around it 845 times, where will I end up? So I'm starting on 0, 1, 2, 3, blah, blah, blah. Where will I end up? In other words, every rotation of 11 just takes me back to the beginning. I don't want to do this manually. Clearly, every mod question could be done by finding the remainder from the division. In other words, if I get 845 and divide it by 11, it'll tell me how many 11s are in there, how many multiples of 11. And however many multiples of 11 will get me back to 0. All I care about is the remainder. Maybe it'll be 1, 2 or 3. My answer is always the remainder. Let's get rid of that silly answer. And it's not even going to be 11. Because if I said 11 in mod 11, the answer would be 0. Because if I go around this clock 11 times, it's the same as doing nothing. But anyway, let's find out. 11's into 8? I don't think so. 11's into 84. Best I can do is 7 11's is 77, which leaves me 7. Bring down to 5. 11's out of a 75. The best I can do is 6 11's is 66. I'll have to load it in there. That's a remainder of 9. I've got no more numbers to bring down. That is my remainder. Oh, there it is. My remainder is 9. I now plan to sing New Step Maths is the best course ever. New Step Maths is the best course ever. Blah, 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 blah. Over and over in a repeating pattern. What will be the 500th word that I sing? You may not look it, but it's the same question as we just had in a way. I don't want to sing it through 500 times. I don't want to sing it at all. But I want to see, well, what's the repetitive loop here? How many bits are in my cycle? This was a cycle of 11 things. That was a longer chant. I'm not going to try and make one up. New Step Maths is the best course ever. I'm going to count. I did that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's a mod 7 thing. There's 7 things and it keeps recurring. Recurring. Okay, no cat jokes, Jimmy. 500 divided by the mod system we're talking is, there's 7 bits in it. Okay, so really what I'm asking myself is 500 moves is equivalent to what in mod 7? That's why it's similar to the last one. Alright, 7s into 5 doesn't happen. 7 7s, I'll do it short division so I don't run out of room. 7 7s are 49. I can take a 49 from a 50. Leaves me 1. 7s out of a 10 is 1, remainder 3. And that's it. I know that if I sing this thing where that's the first word, second word, third, fourth, fifth, sixth, seventh word, the 500th word will be equivalent to the third word. And what's the third word? Is. Therefore, is the 500th. Let's do that then. Okay. Push down, I see. What's the highest common factor of 30 and 45? Okay, the big thing here, that says factor, that says multiple. I think of multiples as big, I think of factors as small. Okay, factors fit inside stuff. So what fits inside of a 30 and a 45? Well, 1 does. Yeah, I agree with you. Yeah, they got 5s in them. 30, that's 250. Yeah, they got 15s in them. 90 might be a multiple. It is a multiple. It's not a factor. So let's just check. But it still could be none of these. But is 15 the highest common factor? It is. I mean, I've got 2 15s here, and I've got 3 15s here. There's no number bigger that goes into both of them. It's great. I could do it manually and write down all the factors of 30 and all the factors of 45, but then it's not really a 1-mark question anymore. Hopefully you can see that 15 is the largest number going into both. The lowest common multiple of 30 and 45, well, we just answered that, I think. We know they're not factors. It's not 15. 45's not a multiple of 30. 90 is a multiple of 30. 90 is a multiple of 45. 330s, 50. Yeah, that's awesome. 90 is the perfect answer. 180 is a multiple, but it's not the lowest one. It's C all the way. Which is a larger number, 83% or 17 on 20? Well, we could convert to decimals, percents, fractions. I would rather go fractions because when I look at 83%, all I'm looking at is a fraction. 83% to me says 83 per 100. 17 on 20 says I can make u 100 on the bottom if I want. I can times u by 5 and u by 5. The bottom becomes 100 and the top becomes, well, what's 5 times 17? It's 5 10s and 5 7s. 5 10s is 50, 5 7s is 35. What's bigger, an 83 on 100 or an 85 on 100? Well, the larger number is the 85 on 100, which is 1720. Therefore, 17 on 20 is the larger. Nice work. Calculate 31 on 40 minus 3 on 8. Please know by now, we don't just subtract the tops or subtract the bottoms. Same with additions, we don't just add the tops, add the bottoms. Plus and minus questions and fractions have always got to have a common denominator. Now, between a 40 and an 8, my method is I walk up to the big one and say, will you do the job? 40, are you a multiple of 8? And the answer comes like, yeah, 5 8s is 40. I could easily convert 3 8s to something on 40. So let's leave the 31 on 40 alone and only adjust the other one to meet it. 5 times 8 is a 40. 5 times 3 is a 15. So all I've done is done the top by 5. I've done the bottom by 5. And now you can see that I've got a common denominator. Once you've got that common denominator, lock it in, it just doesn't change. It's saying 31 of these minus 15 of these is going to be 16 of these. The denominator doesn't change. It's like, what's 31 chairs minus 15 chairs? It's 16 chairs. So 31 40ths minus 15 40ths is 16 40ths. Said simplest form. Alright then, 16 on 40, I can half top and bottom, and 8 on a 20. If I was smarter, I might have spotted that they actually had 2s in common. I mean, I would have got the 2s, 4s in common, or even 8s in common, because look, I can hit halving it. There's my simplest form, 2/5. And if I had spotted it, how many 8s in 16? 2. How many 8s in 45? I could have gone there quicker, but I'm at peace with what I did. Now the next one, okay, we've got some mixed fractions. Leave your answers a mixed fraction. You could turn both into improper fractions and then add them, but with addition, I know in the next we said, look, you can just add the whole bits if you want. It doesn't really matter. You can look at it both ways. Here I'm going to say, well, really that's 3 plus a 4 sevenths plus a 4 plus a 2/3. So I've got a 3 plus 4 in there. I'm going to call it 7, but I've still got to add my 4 sevenths and my 2/3. Now, how am I going to add 4 sevenths and 2/3? Well, I need a common denominator. The 7 can just sit here. 7 threes, I can still walk up to the big one and ask 7, are you a multiple of 3? The answer is no. Okay, what about 2 sevens? Is 14 a multiple of 3? No. 3 sevens is 21. You knew 21 was always going to work just by timesing them. So I'm going to turn them both into 121. The 7 got times by 3, so the 4 should get times by 3. The 3 gets times by 7, so the 2 should get times by 7. And that's telling me I've got 7 plus, I'll lock in that denominator of 21. A 12 plus a 14, what's the 26? But I'm going to leave it like that. The mixed fraction isn't a whole number and an improper fraction. I want to turn that improper fraction into a mixed one. Oh, don't write the answer yet, David. Skip a step. Look at you. 26 divided by 21. How many 21s are in a 26? Just one of them, with 5 left over. So really my question is 7 plus 5 on 21. Plus, oh God, I can't speak today. 7 plus 1 and 5 21sts. The 7 plus 1's an 8. And I've still got those 5 21ths. There's my answer as a mixed fraction. I was saying I could have converted them all. I would have done the left way, that's my happy place. But I could have, that's for practice, I could have converted to something on 7 plus something on 3. And when we do that, it's the 3 times the 7 is 21, plus the 4 is 25. 4 times the 3 is 12, plus the 2 is 14. I need a common denominator, we already know that common denominator is 21. Here I'm just going to do the cross method type thing where I do 3 25s is 75. All I'm really saying is 7 got times by 3, so the 25 gets times by 3. Now the 3 gets times by 7, so the 14 gets times by 7. What's 14 times 7? Well, it's 7 10s and 7 4s. 7 10s is 70, 7 4s is 28. 70 and 28, well that's a 98. 75 plus 98. A nice way to do that in the head is like add 2 to it and take 2 off it. So I'm just thinking, well, it's the same as 73 plus 100. It's 173 out of 21. And now I can see that, well, it said mixed fraction. So let's see how many 21s are in 173. I'm going to cheat. I'm looking over here and saying, oh, it might be 8. Let's check. What's 21 times 8? 1 8 is 8. 2 8s is 16. 168, I can get that out of 173. What is 173 minus 168? That's 8 with 5 left over and 21. What was your preferred method? Like I said, keeps the numbers lower over here. That's my method. That's worth more than 1 mark. It might be 1 mark in the revision paper. That'll be 2 in a final. Now I've got a division question. Now, I'm not even going to try and do any cancelling, not that there's anything. Every division question of fractions turns into invert and multiply. We leave the 18 on 5 alone, but now we times by 25 on 27, which is the reciprocal, the inverse. It's this fraction flipped, upside down, call it what you will. But then please look for cancellations. Like here I've got, well, the 5 and the 25 looks easy. I've got 1 5 in there and 5 5s in the 25. The 18 and the 27, they've got 9s in common. I've got 2 9s in the 18 and 3 9s in the 27. I've got no more cancelling there, I can see, so let's just try it. 2 times 5 on the top is 10. 1 times 3 on the bottom is 3. It says leaving your answer in simplest form. Is 10 on 3 in simplest form? In other words, can I cancel anything out, make the number smaller? No, I can't. We're done. Remember, there's nothing wrong with the improper fraction. You can do an OR. If you want to say how many 3s are in 10, you say the 3 3s are 9 and 1 left over. They're exactly the same answer. Simplest form just means express it with the lowest numbers, not that you have to convert it to mixed. Complete following table, leaving any fractions fully simplified. Well, alright, 7 on 20 is a decimal. It's a percentage. What jumps out at me is, well, firstly, there's one method that always works. I can get the number 7 from the fraction, I can get the numerator, and divide it by the denominator. I could put all sorts of zeros here, and this will always give me my answer. But when I look at that 20, I see you could easily become 100. I could times the bottom by 5 and the top by 5, and suddenly I can see 7 on 20 is 35 on 100. 35% is exactly 35 on 100, they're the same thing. And as a decimal, the number 35 divided by 100, divided by 100 just means 2 moves smaller. As a decimal, it's 0.35. Could I have done it back to what I did on the left? 20s out of a 7 doesn't happen. 20s out of a 70 is 3 is 60, leaving 10. 20 out of 100 is 5. Yeah, whatever you prefer, but that looks like a good way to go to me. Now I've got a decimal as 0.38. It's not far different. Let's use the same tactics. Well, 0.38 is 38 on 100. In other words, as a percent. It's the same thing. 0.38 and 38% are the same thing. Remember, fractions and decimals are odd ones out compared to percents. We times by 100 to convert to a percent. We divide by 100 to convert back. So 0.38 times 100 became a percent. 38% divided by 100 becomes 0.38. While we're at it, that must be 0.12, the next one. Just times by 100 to go right, divided by 100 to go left. And as for the fraction, well, if you've got a percentage, you've got yourself a fraction. That's a 38 on 100, and this must be 12 on 100. But it does say, we like skipping it, but it does say fully simplified. So 38 on 100, or even I can at least halve it and go 19 on 50. No matter how much I keep trying, there's no more common factors left that can simplify that. 12 on 100 could go to 6 on 50, or could go to 3 on 25. That's where I want to go. Effectively divide the top by 4 and the bottom by 4. There it is, a simplified fraction. 3/11 is a recurring decimal. Well, we've had this before, and it's exactly like here. It said that anytime you get a fraction, if you do the division, you'll get the answer, even if it's recurring. So 3/11 is 3 divided by 11. The other big point is, remember please, that this division algorithm, it's like it's backwards. Normally when we do this question, people want to do 11 divided by 3, and then they say, well, there's no 3's coming out of a 1, there's 3 3's coming out of 11 with 2 remainder, and they might keep going on a bit, whatever. But then, can you see a fault? Can 3/11 equal 3.6 something? You know, 3/11 is well less than 1. 3.6 is, well, bigger than 1. I'd like to think that doing it that way, you're coming up with an answer that just, no way. It's got to be this way on the left. How many 11's can I get out of a 3? None. Decimal point above the decimal point here. How many 11's out of a 30? Well, 3 11's are 33, that's too much. 2 11's is 22, remainder 8. 11's out of an 80, best I can do is 7 11's is 77, there's 3 left over. I can see I'm in a pattern already because I'm asking myself a question I've already asked myself. 11's out of a 30, 2 11's is 22 with 8 left over. 11's out of an 8, that's blah 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 blah. And how do we express that? Therefore 3 11's is either 0.27 with the dot over the 2 and the 7 because they're both part of the repeating pattern. Or I could have done 0.27 with a line over both. Make sure it's over both though. And don't write 0.2727 and put the dots over that or the lines. You want to write it when it first recurs, like that. Okay, calculate the following, adding up some decimals. Well, if they're aligned vertically, I've got no issue with it. 0.1, 0.02, I might give another decimal place. 0.33, 0.044. I don't have to put these zeros there for addition, but I like to. I want to see that everything's in its holes. Everything's lined up, the decimals are lined up. So let's add it. 0.04. 2 and 3 is 5 plus 4 is 9. 1 and 3 and the noughts is 4. Yeah. Now with the subtraction, I do want, like, I could write 5.3 directly above and 0.92, but I've got some subtraction stuff to do. I might need to borrow, I need that 0 there. So I'll do it with a plus or minus personally, but you definitely need the minus. Because now it says 0 minus 2 and I know that's a problem. I say, well fine, I'll steal off a 3, bring it back to a 2, and the 1 goes there. Now it's 10 minus 2 is 8. 2 minus 9 is a problem, so I've got to steal off a 5, bring it back to a 4. Now it becomes 12 minus 9 is 3. 4 minus 0 is still 4. The same as the addition, the decimal point, this part of the answer directly in line under the others. Multiplication of decimals. Well, I know with these, we look at how many decimal places are in the question. I've got a total of 5 decimal places in the question. So I should have 5 in the answer. Let's ignore those decimals and stuff and just work out what is 8 by 13. Well, I'll always put the bigger number at the top when doing these multiplications. 3 8s is 24, so 4 down, 2 up, and 1 8 is 8, plus 2 is 10. So the answer is 104, but it should have 5 decimal places. I know my answer stops here, and there's 104 in there. Why am I writing so small? It must have 2 more zeros before the decimal point to give me that number, that 5. Let's write it possibly legible. Yep, there is the 5 decimal places I wanted. My answer of 104 stopped there. I can talk about writing up against a brick wall, but my decimal places don't go to the right. My answer was 104. And yeah, it needed 5 decimal places. I've done it. Now division unfortunately doesn't work the same. The method we did for division of decimals was write it as if it's a fraction. 0.0024 over 0.3. And then we said, I don't care if the numerator is a decimal, but I don't want the denominator to be a decimal. I want it to be a whole number. So all I want to do to correct that is times top and bottom by 10. If the top gets times by 10, that makes one move bigger, 0.024. If the bottom gets times by 10, it becomes a number 3. And that one, I know I can do a division. As long as I'm dividing by a whole number, I can do a division on a decimal. 3's out of 0 doesn't happen, 3's out of 0 doesn't happen, 3's out of a 2 doesn't happen, but 3's out of a 24 is 8. There's my answer, 0.008. That's how we do our decimal divisions. My electricity bill of $250 is due to increase by 12%. What will be the new bill cost? You can think the new bill cost will be 112% of what it was. So if you want, you could times that by 112%. Some of you might times it by 1.12. I don't mean times, I mean or times it by 1.12. But the majority of people will just work out the difference first. That top way I just scribbled is the way to get the answer in one go. But most people will work out what is 12% of 250 and then add it to it. And there's no problem with that. How do I do 250 times 12%? Well, I consider 250 to be the whole number over 1. And 12% is 12 percentaries, 12 on 100. And then I look for any cancellations. Well, a 0 and a 0 off top and bottom. There's no more, unfortunately. I could do, well, I've got options. I might do the 5s. There's 2 5s in 10, and there's 5 5s in 25. I've got a 12 on top of a 2. I've got a single 2 in 2, and I've got 6 2s in 12. The top now says 5 by 6 is 30, and the bottom says 1 by 1 is 1. In other words, $30 is the increase. Don't forget to add it. Therefore, new bill is the 250 plus the 30 is $280. Yeah. Notice I would have gotten straight to the $280 answer if I times by 112 and 100. Your call. Next one, a car one. Drove my car, my new car, for 150 Ks. Okay. And used 12.6 litres of fuel. What's the fuel consumption of a new car in litres per 100 Ks? So we know how many litres we'll take for doing 150 Ks, but we want to know what lower amount of fuel will take to only go 100 Ks. So there's my layout. There's my question. And I want to try and think of something, because I don't have a calculator. What's the biggest common factor between a 150 and 100? What's the biggest number that goes inside of both of them? And often it's a 10 or a 20. I mean, I could do 10. I wouldn't want to do 20. I could do 25s. But look at 50. 50 is the highest common factor between them. And the reason why that helps me is it's easy to get from 150 to a 50. I just divide by 3. And to get from 50 to 100, I just times by 2. As long as I do it to both sides, I'm good. A 12.6 divided by 3, well, let's just scribble down here. 12.6 divided by 3, 3's into 1 doesn't happen, 3's into 12 goes 4 times, and 3's into 6 goes twice. It's a 4.2 litres. So it only takes 4.2 litres to get 50 k's. It's an easy times 2 here to give an 8.4 litres to get the 100 k's. Yeah, I could have brought it down to 10, divide by 15 and then times by 10. Look, there's lots of options, but that was the nicest one in my eyes. Question 3. Water. 5 less than the product of x and y can be expressed as. Firstly, what if someone said, what's 5 less than 7? I'd say the answer is 2. So when someone asks me what's 5 less than 7, I said the answer is 2, because 5 less than 7 means 7 minus 5. 5 less than something is taking 5 off it. So I wanted my answer to be taking 5 off it. Taking 5 off it. Taking 5 off it. Taking 5 off it. What does product of x and y means? That's a times. That's an xy. Not a sum. Not a division. That's a product. That's a product of xy with 5 being taken off it. That's the one. Minus 1 to 101. Well, I know that minus 1 squared is minus 1 times minus 1, which an even number of minuses always becomes positive. I know that minus 1 cubed is minus 1 by minus 1 by minus 1. 1 by 1 by 1 is still 1, but 3 minuses is going to be a negative. And I can see very quickly the pattern. When I raise it to an even number, I get 1. When I raise it to an odd number, I get minus 1. And I'm raising it to an odd number. Minus 1 to 100 might be 1, but minus 1 to 101 would have to be positive 1, negative 1 again. I've got a negative number of minuses lined up, which stays negative. So this is 2/3 of the minus 1. Minus 1 just means 1 over. And in the sake of a fraction, you might already have it written down. One of our Henderson's laws that a fraction with a minus 1 flips it. So what's 2/3 flipped? 3 on 2. So I can already see it's B. But the other thing I could think is it's exactly the same as the question. If I think of 1 over 2/3, well, what did we do to division of fractions? 1 divided by 2/3 became invert and multiply. And what's 1 by 3 on 2? Oh, mate. So either way you think about it, the fraction is about minus 1 gets turned upside down. X to the 5 to the 2. Well, if my indices law is on the sheet, I know that it tells me to times them. When you've got a power to a power, just times them. It's going to be x to the 10. Or I could think, what does it really mean? X to the 5 squared means x to the 5 times itself. So I've got x by x. Yeah, I've got x to the 10. That's how many I've got. E, okay, be careful, y plus y plus y plus y times y. Now, I'm not going to fall into that 4y thing. I know the most important thing in BODMAS here is this times. That happens first. So it becomes y plus y plus y plus a y by y, which is a y squared. And what's y plus y plus y? Well, it's chair plus chair plus chair is 3 chairs. So it's 3 y's plus a y squared. And I can't add y's and y squares. Y's might be chairs, y squares might be tables. They're not like terms. I can't add them. The answer's D. I've got 3 y's and a y squared. Now we've got a substitution, which always the troublemaker will be, make sure that we sub any negatives in brackets. It may or may not matter. But, sometimes it does, so I'm always going to do it. 2p means 2 times p, and p's are 3. Minus and q's are minus 1. Now, it technically didn't matter, but it helps me see that I've got 2 minuses there. There's a minus here, there's a minus attached to the q. It's going to be a plus soon. The r squared was just a 4 squared, plus 2 times q was a 2 times another minus 1. So the top becomes, well, I know that 2 times 3 becomes 6, and this becomes a plus 1. 4 times itself I know is a 16, and a plus 2 times a minus 1 is a minus 2. I know plus times a minus is a minus. 6 plus a 1 is a 7, 16 minus 2 is a 14, and you can see that's a good odd half. There's 1 7 up top, there's 2 7s at the bottom, end up being a half in its simplest form. Now fully simplify the following expressions. that question really says 124 times x to the naught. Now I'm aware that x to the naught is just the number 1. Anything to the naught is 1. It's one of our laws we learned. So really, it's 124 times 1, which is 124. The trap answer would be thinking, well, anything to the naught is 1, so the answer is 1. But that naught is only referring, that power is only referring to the x. The question was not 124x brackets to the naught. That's a different question. Okay, that's 1, because anything naught is 1. But I've got to do this power before I do this times. Just be careful, is the bracket there or not? That proper question just says, what's 124 times 1? Well, it's 124. Next one is x times 3x to the 5. And in my head, I wouldn't normally write it. That to me means x times 3 times x, 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 x. And I can see they're all times's. What's x, 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 x times x? It's becoming x to the 6. The 3 is still there. It's 3x to the 6. If it helps you, you can think of an x as an x to the 1. What's x to the 1 times x to the 5? You add the tops, it's x to the 6. Any x by itself is really raised to the power of 1. It's also got a 1 in front of it, if that helps. Next one says 2x squared times 3x cubed times 4x4. It's pretty similar. Let's do the numbers bit. 2 by 3 is 6, and 6 by 4 is 24. X squared by x cubed by x4. 2 of them plus 3 of them is 5 of them, plus 4 of them is 9 of them. Yeah, done. Now division 1, I'm just going to do this one method, and you can do it in different methods, but I'm going to picture it as 2x cubed y squared over 6xy to the 4. Okay, so that's the same, just written differently. Division means left over right. Now I've got a 2 and a 6, well they can cancel. There's 1, 2 and 2, and there's 3 2's and 6. In other words, I've just halved both numbers. I've got an x cubed on the top and an x on the bottom. Think of x cubed as xxx. I've got an xxx on the top and an x on the bottom. Let's get rid of 1x. X cubed becomes x squared. If I've got a y on the top and a y on the bottom, let's remove 2 y's. Y squared's gone and y4 becomes y squared. What am I left with? On the top it just says 1 by x squared. On the bottom it says 3 by y squared. Simplified. Yeah. The next bit, well, 2 ways to approach. One is I write out what it really means, what squared means. Squared means get everything in the brackets and times it by itself. So it becomes 7x cubed y times 7x cubed y, which you can see that 7 by 7, that's 49. X cubed by x cubed, we've got 6 of them all up, and a y by y, think of a 1 if you want, is a y squared. Or, I could have said that 2 means square everything in the brackets. So 7 squared is 49. X3 to the 2 is an x to the 6, and a y to the 2 is a y to the 2. I think it's safe with the first way with whatever works for it. Okay, expand and simplify that. Well, okay, the 7 is out the front of the brackets, so it's going to times the 2 things in the bracket. Now the entire minus 5 is at the front of the bracket. Be careful here, so you make sure when you do that last expansion, it's a minus 5 times a minus x. So from the start, it's a 7 times an x is a 7x. It's a 7 times a 3, which is a 21, and positive, there's no minuses there. A minus 5 times a positive 2, well that stays minus and 5 2 is 10. And a minus 5 times a minus x has to go plus 5x. Now we've got some like terms. I've got a 7x here and a plus 5x, so that's 12x's all up. I've got a plus 21, got a minus 10, which is just plus 11. 21 to the 10, and that's plus 11. Done. Fully factorise this next one. That's when you try and say, well, what have they both got in common? What's in an 18x squared and a minus 27x cubed? And I picture them as 18xx and minus 27xxx. Numbers wise, between 18 and 27, I can see they've both got 9s in it. That's the highest common factor between 18 and 27. And x wise, x squared, they've both got an xx in it. It's got an xx, that's got an extra one, but they both have an x squared in it. So now I'm thinking 9x squared times what will give me 18x squared. All I need to do is times by 2. 9x squared times what will give 18x squared? 2. Now 9x squared times what will give me this minus 27x cubed. Well, I need a minus 3 to turn the 9 into a minus 27. And I need an extra x to turn the x squared into an x cubed. Now let's undo this and see if we're right. 9x squared times 2 will have to be an 18x squared. Correct. 9x squared times minus 3x has to be a minus 27x squared times x cubed. Yep. I was right. It's fairly successful. I thought I'd go to a class. I'm not paused. Okay. See you soon. Alright, back to it. Now we need to fully simplify this fraction. Now, we know with plus and minus of fractions, we need a common denominator. And here we're pretty lucky. We've already got one. So, the common denominator is 2. And we do what it says to do on the top. It's got an x plus 1. And then we're subtracting an x. Alright, so I can see an x minus x on the top. So they cancel each other. All I'm left with is a half. That's pretty simplified. Now we've got an addition, so we still need the common denominator. Between a 5 and a 4, I'm not going to get anything better than a 20. So let's use the denominator of 20. Now that 5 got times by a 4 to get there. So I better get the 2x plus 2 and times it by 4. But note it's the entire 2x plus 2 that times by 4. So I could either write 4 and the 2x plus 2 in brackets, or I could do it. I'll put that extra step in there. So it's 4 times all of 2x plus 2. Then I've got a plus sign, and this 4 on the bottom, well, it got times by 5. So if the denominator gets times by 5, the top better get times by 5. So it's going to be 5 by a 3x. So now I've got all my scribble in the way. Now look, let's expand these brackets. 4 times a 2x, well that was an 8x, plus 4 times a 2, well that's an 8, plus 5 times 3x, well that's a 15x, and it's all on 20. Alright, 8x plus 15x is 23x. There's still a plus 8, and it's all on 20. And there's nothing I can do that simplifies further than that. I can't add a 22x and an 8, they're not like terms, so we're done. Solve this equation. Now I've got a 5 times an x minus 5. Well, let's expand these brackets. They're not really, I mean they're in the way of us getting all the x's together and everything. So it becomes a 5 times an x is 5x. 5 times a minus 5, well that's minus 25. Equaling, there's no brackets here, there's nothing to expand or do. Now I've got more x's on the left than the right. So good old 5x can sit there. The 2x has got to move. It's a positive 2x, so let's subtract a 2x from the left and subtract a 2x from the right. That leaves me with only a 3x on the left minus a 25 equals, well the 2x got taken away and there's remaining a minus 7. If the x's go on the left, the numbers go to the right. This minus 25, I need to do the opposite and add 25 to get rid of it. So if I add 25 to both sides, the minus 25 and the plus 25 is gone. Just leaves me with 3x equals minus 7 plus a 25. Well, that gives me 18. And then how do I get rid of that times 3 that's sitting here? I better divide by 3. That cancels that out, leaving me with x equals 6. And taking up all the room for the next question. We'll leave more room in the final exam than the revision final. Alright, let's try the next one. Solve that equation. 2x on 3 plus 2 equals 8. Well, I could times everything by 3, or I could take 2 off both sides, and I like getting rid of the plus and minuses first. Let's subtract a 2 and subtract a 2. That leaves me with 2x on 3 equaling a 6, because that got rid of that. Okay, we'll now get rid of this divide by 3. I'll times both sides by 3. On the left, now notice this times by 3 cancels the divide by 3. So I've just got the 2x. We're tempted to think, well I'm going to times the 2x by 3 as well, but no, that's not what we need to do. We already we used the times 3 by getting rid of the divide by 3. They're gone, you've still got a 2x. And 3 6s, well that's 18. Divide both sides by 2. Leaves me x equals 9. Alright, now we want to form this statement into an algebraic equation, which just means if there's an unknown in it, just call it x, n, whatever you want. Here we're talking about 7 less than the product of 5 and a number. Well, a number, let's let the number be x. That'll do. Now the product of 5 and a number would be 5 times x. 7 less than, we already discussed that, 7 less than something is getting the something and taking 7 off it. So there is 7 less than the product of 5 and a number, and we're told that it is 8, as in is many, all of that statement equals 8. So now we just want to solve it any way we want. Let's just do standard algebra, balance method. Let's add a 7 to both sides. Leaves me 5x equals 15. You can see it's going to work out nicely. Divide both sides by 5, and I've got x equals 3. Great. Next one wants me to use inverse processes. Okay, that's the arrows. So that's where I always start with the letter. In this case you can see the letter is x. And we've got some forward operations. I can see a square root sign, a divide by 4 and a plus 3. So I can see 3 things happening. Now the first thing that happened, let's look right on the inside, is I've got an x plus 3 in here trapped. First thing that happened was x got a 3 added to it. And then you can see that that was square rooted. So ended up being the square root of x plus 3. And then you can see that thing got divided by 4, ending up with root x plus 3 all over 4. Alright, so the top line forms the left hand side, and that is equal to the number 1. So now we undo everything in this order the arrows are telling us. The opposite of divide by 4 is times by 4. 1 by 4 is 4. The opposite of square root is to square, and 4 squared is 16. And the opposite of this plus 3 is a minus 3. 16 minus 3, well, that's a 13. In other words, well, I don't need that arrow. In other words, we're meant to say that, well, if they were equal, if everything that happened to the x got undone, the x must have been a 13 to start with. If x equals 13. I might just do a quick check. I'm looking at my answer. That said, if that said 13, the question would say, what's the square root of 16? Which is what's 4 on 4. 4 on 4 is 1. Yep, that all works beautifully. Okay, with question 5, we want, or we've got a statement, 4 more than the square of a number is equal to 20. Let's let the number again be x. The square of x, remember it's not the square root, the square of x will be x squared. 4 more than that, I could put a 4 plus there, or a plus 4 here, makes no difference which side I put a plus 4. It's still the square of a number, and 4 more than it, and it's equal to 20. Alright, there's my equation. So now let's solve it. Let's take a 4 off both sides. 20 minus 4 would be a 16. And here's my alarm bells going off in my head. I'm reminding myself that if I've got a question with a squared in it and I remove it, that there were actually 2 possible answers. Those 2 possible answers, sure, the opposite of squared is square root, and the square root of 16 is 4, but minus 4 is also an answer to this question. If we say what squared equals 16, that means what times by itself equals 16. Well, 4 does, but so does minus 4. Minus 4 times minus 4 equals 16. So whenever you get a squared question, remind yourself, oh, if I'm removing it, there was a plus or minus answer. Not for cubed, not for square root, just for squared in our course. Another equation. Okay, well, last time was a simplify. This one's an equation. I could simplify the left-hand side, but what I'm going to do is what we did in the lecture, which is multiply everything by the lowest common denominator. So I'm going to write it as 3x on 5 minus a 2x minus 3 on 4 equals 1. Now the lowest common denominator here is a 20. 4 5s is 20. There's nothing better than that I can use. So I'm going to do a 20 times here. I'm going to do a 20 times here, and I'm also going to bracket it, because it's not just 20 times a 2x, it's 20 times the whole numerator. So everything's been times by 20. As long as I treated everything equally, that's acceptable. Now, don't do the multiplications yet. Look at the simplifications. A 20 on top of a 5, well, 1 5 in 5, and 4 5s in 20. 20 on a 4, I've got 1 4 in there, and 5 4s in 20, and a 1 times 20, well, I can do that in my head. So what's left? It says 4 times 3x, well that's 12x, minus a 5 at the front of 2x minus 3, equals 20. Since these two fractions only had over 1, I didn't care to write them. I don't need to. Now let's expand these brackets. Minus 5 times a plus 2x is a minus 10x. Minus 5 times a minus 3, careful, is a plus 15. Any like terms on the left? Well, 12x minus 10x, that's 2x. Plus a 15 equaling 20. If the x's are staying on the left, let's get rid of this 15 by minusing 15 from both sides. So if I take it away from the left, it's gone. If I take 15 away from the right, it leaves me with a 5. I'm now going to halve both sides, or divide by 2. So x equals 5 on 2. Nothing wrong with leaving this 5 on 2. Or 2.5, or 2.5, or any variety like that. Next one is similar. I could just multiply everything by 6, which is the lowest common denominator. Or I could do what we said in the lecture, where that 3 multiplies all of this side, and that 2 multiplies all of this side. I'll stick to the basics here, I think. And I'm just going to multiply everything by 20. And you'll see it's the same thing. I'm going to bracket that and put a 20, and I'm going to put a 20 there. So 20 on 2, well that's, you can halve both of them. And a 20 on 3, why did I use 20? Alright, pause. Now there's a couple of ways we can look at this next one, but really it's the same diff. There was a thing in the lecture that said, look, when you've got fraction equals fraction, you can multiply that 2 by this and that 3 by this. But remember, it's the whole thing. It's not just 3 times a 3x, it's 3 times the entire 3x plus 1. Or I could still treat it like the last question where we multiplied everything by the lowest common denominator. It makes no difference. Do as you feel, but I'm going to do that across the shortcut method. It was a 3 times all of that top equals 2 times all of the other side. There we go. 3 times a 3x, that's 9x. 3 times a 1 was plus 3. 2 times a 5x, that's 10x. I've got more x's on the right than the left, so I'm going to let them sit there. And I'm going to take 9x away from both sides. If I remove 9x from the left, it's gone. If I remove 9x from the right, I've only got an x left. X equals 3. Great. Now, what have we got next? Fully factorise. Well, that's when we take out the biggest or highest common factor of both of these terms. We've got this term and this term. Now I can see there's a 5 in both of them as the highest common factor. Definitely 5 and 10, you can take a 5 out of both of them. If I've got an x squared and an x, I can take an x out of both of them. No more, but I can take an x out. So if I'm saying I can take a 5x out the front in total, well 5x times what gave 5x squared? 5x times x gives 5x squared. 5x times what would have given the minus 10x? Well, that better be a minus 2. Let's check. 5x times x is 5x squared. Check. 5x times a minus 2 would be a minus 10x. Everything's good. Now you use the result from part 1 and the null factor law to solve that exact same statement, but equals 0. Means I can write 5x outside of x minus 2 equals 0. And whenever we've got something times something equaling 0, I know that, here's the times, right in here, either this side is equal to 0, 5x equals 0, or this side is equal to 0, x minus 2 equals 0. 5x equals 0, I can divide both sides by 5 there. That just leaves me x equals 0 on 5. Well, how many 5's going to get out of a 0? It's still 0. We're always going to get x equals 0 as a solution. The other side, if I add 2 to both sides, becomes x equals 2. Now let's see if my answers are true, because I reckon my answers are x equals 0 or x equals 2. Well, if it's 5 times 0 times whatever, yeah, that's 0. But if I put a 2 in there, 2 minus 2, that's 0 times whatever is 0. Yep, we've got our answers. Let's see the subject of the formula. Well, C is trapped over here at the moment. Let's get rid of the easy plus or minuses first. Let's subtract a b from both sides. Take a b away, take a b away. So I'm trying to get down to just a c on the right. So on the left, if I take a b away from a, all I can do is write a minus b. And the b is gone from the right. And now I've got to multiply by d to get rid of the divide by d. Well, on the left, all of a minus b has to get times by d. So I'm going to do that. D times all of the a minus b. And then equals, why is there a, there should be an equal sign there. On the right, well, if I times the right by d, we're just left with c. There it is, I can rearrange if you want. C equals d outside of a minus b. Rearranged. Alright, make r the subject of the formula. I don't want it on the bottom. Let's at least remove the whole r squared, which at the moment is dividing the right. So if I multiply the left and right by r squared, the left will become ar squared and the right will just become gm, because the r squared multiplied it. Now I want, well, let's get rid of the a, because I want the r squared at least by itself. Let's divide both sides by a. On the left it disappeared, and on the right it became gm on a. And how do you remove a squared? Well, I know that the opposite is square root. But what I've got to remember is, even when it's pure algebra, there are two answers to a squared question. If I take a squared away, I've got to remember a plus or minus comes into it. So r would equal plus or minus the square root of a gm over a. Next, okay, we've got a simultaneous equation happening for lots of things. Let's check. Adult tickets for entry to a museum are twice the price of the child tickets. For a school outing, I purchased 3 adult tickets and 28 child tickets for $204. What was the price of an adult ticket? We could do this with one variable or two variables. It's true that I could let a equals the cost of an adult ticket and c equals the cost of a child ticket, and I could carry on and do it like simultaneous equations. Or I could just do it with one. I'm going to do it with one because it says what was the price of an adult ticket. If that's all I care about, if it's only a find a question, well, I'm going to let a equals cost of adult ticket. In other words, all I want to know is what's a? And it's in dollars. Now what I'm going to do is, if the adult tickets are twice the price of the child tickets, I know that if a is the cost of the adult ticket, a on 2 must be the cost of the child ticket, half price. So I've got fractions in the way I'm doing it, but well, I'm okay with it. But still, you could have let maybe c be the cost of the child ticket, therefore the adult cost 2 times c. Lots of ways to do it, but I'm sticking with this. Let's see if it's okay. For a school outing, I purchased 3 adult tickets. So that's 3 times the cost of $8 each, plus I bought 28 times the cost of a on $2 each, because that's the cost of a child ticket, and that cost me $204. I'm pretty okay with this. Notice here, the 28 is like a 28 on 1. I can simplify this a bit. Cancel the 2 on the bottom with the 28. So I've got 1 2 in 2 and 14 2s in 28. So all it's become is 3a plus 14a equals 204. Well, 3 things plus 4, that's 17 things equals 204. If I then do what's 204 divided by 17, let's check. What's 204 divided by 17? 17's out of a 2 doesn't happen. 17's out of a 20 goes 1, 2, 3. 17's out of a 34. Well, 2 17s make 34. So a equals 12 is the answer. Therefore, that's all I wanted to know. Adult tickets were $12. And I don't need to go back. Even though, let's look at it, the child tickets would have been 6. Okay. Use algebra to find 2 numbers which have a difference of 7 and where the sum of 4 times a larger number and 5 times a smaller number is 100. Alright, 2 things. We need to find a larger number and a smaller number. I'm going to define my variables that way. Let L equals the larger number. Let S equals the smaller number. Now if their difference is 7, is that larger minus smaller or smaller minus larger? It's definitely larger minus smaller to get a difference of positive 7. The larger number minus the smaller number is 7. Yeah, difference 7. The sum, well the sum means plus, of 4 times a larger number So 4L, and 5 times the smaller number, 5S, is 100. That's what that second sentence is saying. The sum, adding 4L's and 5S's is 100. So we could now proceed via the elimination method or the substitution method. It doesn't really matter. I think I will go the substitution method here because it's just what people like most. Well, let's just do both. If I go the substitution method, that's when I rearrange one of them to an L equals or an S equals. Let's just change equation 1 here into an L equals by adding an S to both sides. So if I add an S to the left, it's just an L. If I add an S to the right, it becomes S plus 7. And then what we do is sub that in to the other equation. The other equation said 4 times L, but instead of writing L, I'm going to write S plus 7. It's going to get rough because my S's look like 5s. Plus 5S equals 100, so I've just rewritten the second equation, but instead of writing L, I write S plus 7. 4S plus 4 7s is 28, plus 5S equals 100. Well, 4S plus 5S, that's a 9S, plus 28 equals 100. Let's take that 28 off both sides, and that gives me 72. So S is equal to 72 on 9, and 9 8s is 72, so S is 8. And then we sub that answer back into the other equation. If L equals S plus 7, L equals 8 plus 7, because S is 8. So there's one way to go about it. I found that the larger number is 15, and the smaller number is 8. The other thing I could have done is done it by the elimination method. I don't have a lot of room, but I could have said, oh, that's a 4L, that's an L, that's a 5S, that's a minus S. None of them have the same number in front of it. But I might have said, look, I wouldn't mind if that said minus 5S and that said plus 5S, because then I could just just add them. So if I times all of the first equation by 5, that would give me 5L minus 5S equals 35. All I did was equation 1 and times it by 5. Alright, now let's add equation 2 and what I'll now call equation 3. The 4L plus 5L is 9L, the plus 5S and the minus 5x makes 0, and the 100 plus 35 is 135. If I now divide both sides by 9, I'll get L equals 15. If we do a short division, but I'll get L equals 15. You can see that was it. And then I sub that into whichever one, maybe into this one, which tells me 15 minus S equals 7. So minus S equals, take 15 off both sides, 7 minus 15, well that'd be a minus 8. So I can make both sides a plus by timesing both sides by minus 1. So here I've got S equals 8 and L equals 15. Same answer obviously for both. Cool. Now, it doesn't matter which way we solve it, but this is so set up for elimination method in my mind, because they're all in their columns. But maybe you could change that to x equals 29 minus 5y and sub it into the other. That's okay. But I'm going to go ahead this way and say, look, I'm going to just pick on, it'd be easy to turn this equation 1 into 3 x's. So I'm going to get equation 1 and times it by 3. So instead of x, I've now got 3x. Instead of plus 5y, I've got plus 15y. Instead of equals 29, I've got equals, 3 20s is a 60, and 3 9s is a 27. So equals 87. I'm going to call that equation 3 now. So if I've got equation 2 there and equation 3 there, I've got to do a subtraction. 3x minus 3x will disappear. I'm going to do 3 minus 2, so I'd rather do the bigger minus the smaller. 15y minus a minus 7y is 15y plus 7y. That's 22y. 87 minus minus 1 is 87 plus 1, which is 88. Divide both sides by 22. How many 22s and 88? 4 22s make 88. So we've found y, and now we just sub into equation 1 will do me. X plus 5y equals 29. Well, instead of y, I know y is 4. So x plus 20 equals 29. Let's take 20 off both sides and get x equals 9. So we've got both answers, y equals 4, x equals 9. Another simultaneous equation. Must be predictable stuff. Jen and Kevin went to the show. Jen bought 1 fairy floss and 2 Pluto pups for $5.60. So clearly, I'm just skim reading here, I can see we're talking about the price of fairy floss and the price of Pluto pups. F can be equals the cost of fairy floss. Now let's just $5.60, $13. I'm just going to stay in dollars anyway. I'm not going to convert to cents. We'll see. P can equal the cost of a Pluto pup. So if Jen bought 1 fairy floss, well that's just 1 F, or F, plus 2 Pluto pups, that's 2 P's. Give me $5.60. That's what it costs. The other one says Kevin bought 5 fairy flosses, 5 F's, plus 4 Pluto pups, and that costs $13. Alright, equation 1 and equation 2. Now you can look at the options. I'm going to eliminate again. I could just times equation 1 by 2, then it'll have 4 P's in it. And that'll have 4 P's. Or I could do equation 1 times 5, and then they'll both have 5 P's. I'd rather keep the number small. By 2 will do. Equation 1 times 2, F will become 2F, 2P will become 4P, and $5.60 will become $10 plus $1.20, it's $11.20. And now let's do a subtraction. Because a 4P minus a 4P, whether I go top minus bottom or bottom minus top, they're going to eliminate. And I'd rather do big minus small, as in 5F minus 2F. So I'm going to do 2 minus 3. Equation 2 minus equation 3. 5F minus a 2F is 3F. 4P minus a 4P is gone. $13 minus $11.20. Well, that's $1.80. Great, 3F is $1.80, divide by 3, F equals 0.60. So fairy floss must be 60 cents. And we sub that back into one of them, just the original will do. F plus 2P is $5.60. So in other words, 60 cents plus 2P is $5.60. Take 60 cents off both sides, gives me 2P equals $5. And if I divide $5 by 2, gives me a Pluto pup must have been $2.50. Therefore I'd summarise and say fairy floss is $1.60 and Pluto pup is $2.50. Okay, water. Express the following as a number as a basic unit. Okay, so 3.2 by 10 to the 5 is basically a 3.2. It was times 10 5 times. Let's put some zeros here. And just, it's 5 moves. I'm not counting zeros, it's 5 moves. 1 move, 2 moves, 3 moves, 4 moves, 5 moves. There's my answer. It's not there anymore. My answer is, I'm trying to get rid of that, make it not look like there's still a dot there. Yeah, so neat, David. My answer is 320,000. Yep, 5 moves bigger. The next one is similar, but it's got the minus there. So it's 6 moves smaller, which is that way. So it's an 8.41. I'm going to stick some zeros here. 6 moves smaller. 1, 2, 3, 4, 5, 6 moves smaller. There we go. I should write meter. 0.0000841. Now going the other way. I know that we want our decimal point here. We want one non-zero to the left of it. So I'm going to write 4.321. I don't need them. Times 10 to that. Now I know it's a positive power, but how many moves did it make? The decimal point used to be right here. 1, 2, 3, 4, 5, 6, 7, 8 moves to get it where we wanted it. Similarly, I want my decimal point here, one non-zero to the left. So it's going to be 6.0000048. We don't just round it. This isn't rounding. Whatever digits there, I'm still going to write them, unless there's zeros at the end. Times 10 to the. Now I know it's gone smaller. There's not much remove, is it? It was here, and we've only moved it 2 spots. So it's 6.000048 by 10 to the minus 2. only 2 moves. Next one, okay, if we're going to multiply these scientific notation numbers, they're all timesers, so I can do the 2 by 3, that's a 6. And 10 to the 3 by 10 to the 2, I know that's the 10 to the 5. Either by thinking I just add the powers, which I've done, or there's 3 10s here and 2 10s here. If I see there's 5 10s all up. Next one, 3 times 5 is 15, so I've got alarm bell again. This is that trap one, where I'm going to get an answer then have to modify it, because I really want my answer to say 1.5. But at the moment, 3 5 is 15. At the powers, I've got a 10 to the 4 and a 10 to the 6, so that's a 10 to the 10. But scientific notation says I need my decimal point there. So if I'm going to make 15 one move smaller, that's okay. You're going to make the other number one move bigger to count for it. There's the final answer there. Then we're getting a bit nasty. It's still a times, but I've got a 1.2 times a 2.4. So that's taking us back to decimals, week 5 or something. 1.2 by 2.4. Someone asked me how to do 1.2 times 2.4. First thing I say is count how many decimal places in your question. There's 1 there and 1 there. So there's 2 total decimal places. Then I say ignore them. Do what is 12 times 24? Well, 12 times 24. 2 4s is 8 and 4 1s is 4. But the naught there counts for 2 being really a 20. 2 by 2 is 4 and 2 by 1 is 2. We add these up, 8, 8, 2. So my answer to that was 288. But like we said, there were 2 decimal places. There should be 2 in the answer. So what's the answer to 1.2 times 2.4? I had peanuts, it's stuck in my throat. This really bugging me. Okay, that's fun. Now, so that's that bit, times by 10 to the minus 3 by 10 to the 7. We just add the powers. What's a minus 3 plus a 7? Well, 7 steps on from minus 3 is a 4. And that's good, I don't need to change the answer, because it's a 2.88 times 10 to the 4, that's scientific notation. Got a bit nasty with it, but there we go. Now, I've got to watch, oh, we've got to divide, don't keep timesing, David. We've got 2 divides coming. Firstly, what's a 9 divided by 3? A 9 divided by 3 is 3. What's a 10 to the 3 divided by a 10 to the 5? Well, our laws for 10 to the 3 divided by 10 to the 5 was you did a subtraction on the power. What is the number 3 minus 5? It's a minus 2. We're done. That's scientific notation. It's all good. Next one, a 9 divided by 2. Well, what's half of 9? It's 4.5. 4.5. Alright, good start. What's a 10 to the 5 divided by 10 to the minus 6? Well, we've got to do a subtraction on the powers. What's 5 minus minus 6? Well, minus minus, it's got to be 5 plus 6. 4.5 by 10 to the 11. Okay. Next, we've got 3 significant figures. I will walk up first, second, third significant figure. I'll put a line there. Will I leave the 4 alone or take it up? Well, it's followed by an 8, so I will take it up. So 1.25 is what I'll do there. 3 significant figures, first, second, third, put a line. Will I leave the 8 or take it up? It's only followed by 2, so leave it alone. So 4, 6, 8 are the first significant figures, but I've got to put a 0 in, because it still should be 4,000. Okay, the 4 needs to still be in the thousands column, so I had to put a 0 here. So for any whole numbers you're removing, you've got to fill it back with a 0, like the next one. 1, 2, 3, there's the first 3 significant figures. Should I leave the 3 alone or take it up? Well, it's only followed by 4, so I'd leave it alone. And again, these whole numbers that I've just gotten rid of, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I know it's an old way to write things with the commas, but you can see my answer is still 12.3 million is still close to the initial question. But yeah, it's only given 3 significant figures. Not 3 figures in total, 3 significant figures. The last one here, we don't start counting significant figures until the first non-zero. So first, second, third significant figure. Will it be 2, 3, 4, or should I round the 4 up? It's followed by 5, so I should round the 4 up. So it's going to be 0. How many is there? 3. 0, 0, 0. 2, 3, but not 4. 2, 3, 5. It got rounded up because the 4 was followed by 5, so up it went 0.000, 2, 3, 5. Now, how many millimeters in a meter? Well, I know I've got that thing where I go mega, kilo, no prefix, milli and micro. If I'm talking about millimeters, so it's like megameter, kilometer, meter, millimeter and micrometer, how many millimeters are in a meter? It's only one leap up here, and you know each leap is 10 to the 3. Hopefully you know there's 1,000 millimeters in a meter. How many centimeters cubed in a litre? Well, my graphic of the size I can help here. I need to know how centimeters cubed and litres relate. And one thing I know is 1 centimetre cubed is the same as 1 mil. So how many centimeters cubed? I can replace centimeters cubed exactly. And I'm asking now how many mils are in a litre. Same question as before. Mils would be milliliter. Litres would be no prefix. It's like I'm changing all of these M's to L's. How many milliliters in a litre? 1,000 of them. It's only one leap up the scale. How many micrograms in a kilogram? I don't particularly care about the gram bit. How many micros in a kilo? 1 leap, 2 leap, 3 leaps. And each leap was 3. So that's 9. Oops, I've circled the wrong one. Rather. The last one's how many milliliters in a mega? Well, milli is here. Go to mega, 1, 2, only 3 leaps. From milli to mega is 3 leaps. It's another 10 to the 9. Now, conversions. Got 12.8 centimeters to meters. You might be able to do it without this fractional method. But I'm going to say I've got 12.8 centimeters. And since it's got no denominator, I'm going to put it over 1. I'm going to say I don't want centimeters. So if cm's on the top, I'm going to put cm on the bottom. I do want meters, so this little conversion factor is going to change it to cm to m's. Now, what do I know about centimeters and meters? I know that 1 meter equals 100 centimeters. So the centimeters is gone, and it's telling me that 12.8 is over 100. So it's 2 meters smaller. 1, 2. So my answer is 0.128, and the only letter left is n. So 12.8 on 100 meant 2 meters smaller. That's exactly what I did. 0.128 meters is 12.8 centimeters. Now I've got a 1.6 by 10 to the 8 litres. Again, I'll put over 1. And I want to get rid of litres, so litres on the top, I'll put litres on the bottom. I do want megalitres, and I've got to think, well, how do megalitres and litres relate? And I know that litres would be here and megalitres here. It's 2 leaps. 1 megalitre is 10 to the 6 litres. Yep, in other words, mega does mean million. So let's look at the division I've got. Litres has gone, so my answer is in megalitres. Great. The 1.6 times 1 divided by 1, they don't do anything. So it's still a 1.6, but I've got a 10 to the 8 divided by a 10 to the 6. We subtract the powers there. 10 to 8 divided by 10 to the 6 is 10 to the 2. And we've got megalitres. Yep. Now I've got a centimetre squared to metre squared. I've got to do I've got to do something twice. Whichever way I do it, I'm going to still stick with the conversion factor. I'm going to write down 86,000 centimetres squared over 1. I don't want centimetres, so get rid of it off the top. I'm putting it on the bottom, but I'm going to have to write it twice. I do want metres, so I'm going to write the exact same conversion factor. It's the same one I did before. 1 metre is 100 centimetres. So centimetres squared cancels out with centimetres. The centimetres from centimetres is centimetres squared. And I've got, well, 1, 2, 1, 2. Zeros I can cancel. 1 more 0 on the top, 1 more 0 on the bottom. Now I'm left with an 86 by 1 by 1 mm is 86m squared. On the bottom I've got 1 by 1 by 10. And what's 86 divided by 10? Well, that's just an 8.6 divided by 10 is 1 move smaller. Done. 0.035 metres cubed, centimetres cubed. I've got to write something 3 times. Good luck. 0.0035. I've got to go past again in a sec. Metres cubed, I'll put it over 1. I don't want m, so m's go to the bottom. And I'm doing it 3 times. I do want cm, so that goes on top. How do m's and cm's relate? Well, 1m is 100 centimeters. So make them all like that. M cubed is cancelled, the m. My answer is now in centimeters cubed, but I've got to times that decimal by 100 times 100 times 100. The first times 100 makes it 0.35, the second times 100 makes it 35, and the third times 100 would make it 3500 centimeters cubed. That was 6 moves bigger. For 1, 2, 3, 4, 5, 6 zeros, 6 moves bigger, ended up at 3500. Next one, 180 litres per minute. These, I think this would normally be 2 marks, but anyway, in the revision paper, we're stingy. 180 mils per minute. That is a fraction one, so I don't need to write over 1. It already is. 180 mils in 1 minute. Now, it doesn't matter whether I pick on the minutes to hours or the mils to litres first. Let's go to mils to litres. I don't want mils, it's on the top, so I'm putting it on the bottom. I do want litres. How do litres and mils relate? Well, 1 litre is 1,000 mils. So the mils is now gone. The other thing I want to get rid of is min. So the min is on the bottom, so I'll put min on the top. And I want mins converted to hours. How do minutes and hours relate? Well, I know 1 hour is 60 minutes. Yep. So min is gone. Now any other cancellations? I've got that 1 0 and that 1 0 can go. Another 0 at the top, another 0 on the bottom. I've got a 10 on the bottom and an 18. I can halve the 10 and halve the 18. Nothing left to do to cancel. 9 times 1 times 6 is 6 9s is 54. 1 times 5 times 1 is just a 5. The letters left on the top were litres. The letters on the bottom were hours. So I've got 54 and 5. Now, this actually would have been easy if I'd done one less simplification. But it doesn't matter, I've got a 54 and 5. We can do that. What's 54 on 5? Well, that's 5s out of 5 goes once. 5s out of 4 doesn't happen. So I've got 4/5 left. So I could call it 10 and 4/5 litres per hour. I could also have called it 10.8 litres per hour. Because 4/5 and 8/10 is the same thing. Yeah, whichever way you went. Next one, 30 metres per second. Wait, page up. Here's 30 metres per single second. Metres is going to kilometres, seconds is going to hours. Let's get rid of the metres first. M on top, M on bottom. M replaced with km. I know 1 km equals 1,000 m. Metres is gone. Now let's get rid of the seconds. S is on the bottom, so S goes on the top. And and H goes on the bottom, seconds to hours. I know that 1 hour equals 3,600 seconds. Remember that came from the 60 seconds in a minute and 60 minutes in an hour. 6 6s are 36, plus those 2 zeros. Yep, there it is. So now seconds is gone. Cancel some stuff. Ooh, this is nice. I've got 1 2 3 zeros on the top and 1 2 3 zeros on the bottom. How nice is that? The bottom is 1 by 1 by 1/8. So all I've got to do is what's 3/36s. I'll go to the side and do that, and it'll tell me it's 108 kilometres per 1 hour, which is good old 108 kilometres per hour. Oh, we're so close, but I've got to go. Alright, I'll be back. Okay, back. Using the exchange rate for the Australian dollar, Japanese yen, of 1 AUD equals 80 yen. So we start off with how much is 40 AUD. So we always start off with, write down what we're discussing. We're talking about 40, oh you're so messy, 40 AUD. I'm going to put over 1, like all the other conversions that weren't already fractions. Now, since AUD is on the top, I'm going to put AUD on the bottom to cancel it, and I want to convert it to yen, and this conversion tells me that 1 AUD equals 80 yen. So I know that was always 50-50. I was always going to divide by 80 or times by 80, and this is telling me AUD is gone. It's 40 times by 80, not divide. 4 eighths are 32. Tack on those 2 zeros, and the units are yen. Now we're going the other way around, 1200 yen. But this time, if I'm trying to get rid of yen, I'm going to write yen on the bottom and AUD on the top. Clearly this time, if 1 AUD is still equal to 80 yen, it's a divide by question. Yen is gone, so I can see my answer will be an AUD, which is what I want. Let's simplify a bit. Let's remove 1 0 off the top and 1 0 off the bottom. Now I've got 120 on 8. Truth is, I could go in and I could do that division, what's 120 divided by 8, or I could keep simplifying. Half of 8 is 4, half of 120 is 60. Let's do it again. Half of 4 is 2, half of 60 is 30. Let's do it again. Half of 2 is 1, half of 30 is 15. Alright, my answer is 15 times 1 on 1 times 1, it's 15 AUD. But again, when it said 120 on 8, I could have come over here and said, ooh, what's 120 divided by 8? 8s in a 0 doesn't happen, 8s in a 12 goes 1 with 4, 8s in a 40 goes 5. So I could have gone straight to the answer of 15, but that was, well, more fun. More exchange rate. We've got decimals involved, so that's going to be the testing point. $40, we're starting with 40 Australian dollars again, over 1. I don't want AUD, so down it goes. I do want euro, so up it goes. And it says 0.7 euro is 1 AUD. AUD is gone. So it's a times. 40 times 0.7. Our method again with that was count how many decimal places you've got, and I've only got 1. So 40 times 0.7, well now let's ignore it. 40 sevens, or 4 sevens is 28. Plus a 0, it's 280. And it should have 1 decimal place. So the answer is actually 28.0 euros. 28 euros. Alright. And now to convert 210 euros to Australian dollars, well, here's 210 euros over 1. Euros on the bottom this time to get rid of it off the top. And 0.7 euros is equal to 1 AUD. So euros is gone, and you can see it's a divide by question now. So I've got 210 on 0.7 AUDs. Remember what we did with division? We said, I don't want to divide by a decimal. I want to times you by 10. Alright, as long as I times the top by 10 as well, 210 becomes 2,100, 0.7 becomes 7. And what is 2,100 divided by 7? Just move to the side and say 7 out of 2 doesn't happen. 7 3s are 21, 7 out of 0, nope, 7 out of 0, nope. The answer is 300 Australian dollars. And we made it, I believe, to the end. Alright. All the best with it.